Can you see my screen?
Yeah, it's just loading.
I think we had done this topic before.
I'm not sure.
Not sure. Okay, we continue, right?
Okay.
How to increase the size? Okay, this is better. First of all, I'm talking about what is meant by an acid, right? Acid is a substance which donates a pair of electrons, which donates H positive ion, or which furnishes H positive ions. In aqueous medium. Right?
Yeah.
For example, if I say HCl, it can give H positive and Cl negative ion. So HCl is an acid.
Yes.
So it is giving one H positive ion only, and that is why we call it is a monobasic acid. And it is undergoing complete dissociation. It is undergoing complete dissociation, and that is why we call it is a strong acid. So it's a strong acid and it is a monobasic acid, right?
Yeah.
And if I say sulfuric acid here, it can give 2 H positive ion and 1 sulfate ion. This is a dibasic acid. And it is also undergoing complete dissociation, so we call it a strong acid. But if we talk about this molecule now, that is acetic acid. This does not undergo complete dissociation. Means all the molecules do not dissociate in water. Some molecules remain undissociated, so we call this is a weak acid. And it is giving only 1 H positive ion. Again we say this is a monobasic acid. Right? Getting me? So this is an acid. And now we talk about what is the base. Right? What is a base now? Base is a substance which donates OH ions, or which furnishes OH ions in aqueous medium. For example, if I say sodium hydroxide, so it will form here Na positive and OH negative ion. It is giving only one OH ion, so it is called as a monoacidic base. And it is undergoing complete dissociation, so we call this is a strong base. Getting me? Now talk about this magnesium hydroxide. So it is a diacidic base.
Right.
Diacidic because it can give 2 OH ion. Undergoing complete dissociation, so this is also strong base. But we talk about this ammonium hydroxide. This is undergoing incomplete dissociation and forms here ammonium ion and OH ion. And
so if it has to be complete dissociation, all of the elements have to be separated.
Yeah.
All the compounds.
Yes.
Yeah.
It is now weak base here because it is not undergoing complete dissociation now. And again it is a monoacidic base. Monoacidic base. Is that clear?
Yes.
The definition is now clear, right? Acid, alkali, the two things are clear now?
Yeah.
Okay. What is salt now?
It's Oh, no, I just have a question. I don't get what the difference is between an acid and a base. An alkali and a base.
Okay. Which is the source of OH in the aqueous solution is the alkali, right?
Mm-hmm.
And the substance that neutralizes the acid by combining H positive ion is in them is called the base. Suppose I say we neutralize the acid by combining with H positive ions in the aqueous is called as the base. Okay. Let's take it like this. Suppose I say I have an HCl. HCl is acid, right? And NaOH is a base.
Yeah.
Its H positive ion is neutralized by the OH ion by combining with it and form water and NaCl. So this is a base. But any other base, right? Any other base which is a source of OH ion, but may and may not give the OH ion, that it will be alkali. Right. So this is a salt. Salt is formed by the combination of acid and base. Right? I know it's clear now, right?
Yeah.
So you can say if with any base HCl combined and it forms a NaCl, we call chlorides. With the nitric acid, we call nitrates. With the sulfuric acid, we call sulfates. Phosphates, ethanoids.
Yeah.
I give you one particular example with this one, right? For example, if I have a base like sodium hydroxide and I neutralize this with the acid HCl, so we call it a sodium chloride.
Yes.
And now suppose I am neutralizing this base with nitric acid, HCl3. I'll get here sodium nitrate and water.
Yeah.
Sodium nitrate, right? And if I neutralize it with acetic acid, it will form here sodium ethanoid. Getting me?
Yes.
Sodium ethanoid. And if I neutralize it with phosphoric acid, H3PO4, it will be giving you this way, right? Sodium phosphate. So depending upon with which acid we are neutralizing it, it will be called like chloride, nitrate, sulfate, phosphate, etc. Right? So metals which are above the reactivity series, above the hydrogen, they react with the acids. Do you know the reactivity series?
Yeah.
Can you tell me the sequence of the reactivity series?
Yeah, it's first it's potassium, then it's potassium, then sodium, then calcium, then magnesium, aluminium, carbon, zinc iron,
right?
Then tin, then lead, hydrogen, copper, silver, and gold.
Okay, good. So elements which are above the hydrogen means they are more reactive, right? Let it be, it is a potassium. They will react to the HCl. And they will form potassium chloride and hydrogen gas. Right? Let it be calcium here, that will react to the sulfuric acid. this way.
Mm-hmm.
So all the metals which are above the reactivity series react with the acid and form salt and hydrogen. With the sulfuric acid they form metal sulfate, salt and hydrogen gas. But all the elements which are below the reactivity series, below the hydrogen, they do not react with acids.
Yeah.
Right. For example, if I talk about any other metal like copper, if I react to the HCl, it is below the hydrogen in the reactivity series. So no reaction will take place here.
Okay. What about alkalis? Do they react?
Pardon, I'm not getting you.
Do alkalis react with metals below hydrogen in the reactivity series?
No. Okay. Now see, with the magnesium, with the sulfuric acid, it form magnesium sulfate and hydrogen gas. And as the hydrogen gas comes out, it comes out more vigorously, rapid fizzing. Right? The reaction mixture becomes warm, and we say that reaction is exothermic. Magnesium disappears, and colorless solution is formed. What is that colorless solution? That is basically magnesium sulfate. Getting me?
Yeah.
Okay. So with the HCl, it will form MgCl2 and H2 gas. That H2 gas comes out with a rapid fizzing, and the solution that is formed is colorless. And again, it is an exothermic reaction. Heat is liberated. Any doubt in these reactions?
No.
It's simple. It's simple, right? So we can write this equation like this. Sulfate ions are not involved in any change. Earlier it was combined with H positive ion, now it is combining with the magnesium ions. So we can write an ionic equation. Because sulfate ion is common, we can remove the H positive sulfate ion. Similarly, in the second case, we can remove the chloride ions.
Yeah.
They're common. Right?
Yeah.
See down this question with the zinc HCl, sulfuric acid. It forms zinc sulfate and H2 gas. Zinc with HCl, it forms ZnCl2 and H2 gas. Zinc reacts slower than magnesium because magnesium in the reactivity series is below the reactivity series, right?
Yeah.
The one that is below in the reactivity series, they are comparatively low reactive, less reactive.
Yes.
So zinc disappears and colorless solution is formed, right? But it is slow as compared to magnesium. Right? So
yeah.
I think these 4 points are clear. What is acid, what is alkali, what is base, what is salt, right? Okay. I think it's a repeat same thing, right?
No, they all have the same front first slide.
Okay. See now the base, which neutralize the acid by combining with H positive ion in them. Right? Metal oxide, metal hydroxide, ammonia, carbonate, these are the bases here. Right? Copper oxide plus acid, they form salt and water. Right?
Yeah.
So copper oxide is a base here. Ammonium sodium hydroxide is a base here.
Yeah.
Because they're combining with the H positive ion of the acid. So base is a substance which neutralizes the acid by combining with H positive ions in them. Whereas alkali is a substance which acts as a source of OH in the solution.
Yeah.
So I can say in this case, sodium hydroxide is a base. But copper oxide is and copper oxide is a alkali here.
Alkali. Yeah.
Right.
Yeah.
Copper oxide is a base, and alkali is the one which is a source of overjoin, right?
Mm-hmm.
So it means sodium hydroxide is a alkali and copper oxide is a base.
Base. Yeah.
So what is Na2O? In water it will give NaOH, so it will be an alkali.
Alcohol.
But only Na2O is a base.
Base.
K2O only is a base, but Na is
In water, it's
yeah,
alkaline. Yeah.
alkali, right?
Mm-hmm.
So ammonia plus water it form ammonium hydroxide.
Mm-hmm.
Base that neutralizes the acid by combining with the H positive ion in them. You can see copper carbonate, it is green in color.
Mm-hmm.
With sulfuric acid become copper sulfate, water is lost. So we can say if this is a acid, then copper carbonate is a base.
Mm-hmm.
If nitric acid is an acid, then copper carbonate is a base.
Mm-hmm.
If HCl is a acid, then copper carbonate is a base.
Base.
Are you understanding these reactions?
Yes.
Yes. So the solubility of the ionic compound in water now.
Mm-hmm.
All the sodium, potassium and ammonium carbonates are soluble in water.
Mm-hmm.
All the nitrates are soluble in water. All the chloride except AgCl and PCl2 are soluble in water.
Mm-hmm.
All the sulfate except silver sulfate, lead sulfate, barium sulfate, copper, calcium sulfate, these are soluble, right?
Mm-hmm.
But the carbonates are mostly insoluble except for sodium carbonate, potassium carbonate and ammonium carbonate.
Mm-hmm.
Most hydroxide except NaOH, KOH, ammonium hydroxide and calcium hydroxide, these are insoluble.
Mm-hmm.
Right?
Mm-hmm.
You have to remember these things. It's a fact.
Yeah.
Now, acid and a metal, they form salt and hydrogen. But which metal? Only those metals which are above the hydrogen in the Titration series. Right? Like magnesium with a sulfuric acid, it forms magnesium sulfate and hydrogen gas. Metal acid plus metal oxide to form salt and water. Right?
Mm-hmm.
So it will form a copper sulfate and water.
Yeah.
Acid plus carbonate, it forms salt, carbon dioxide and water. Right?
Mm-hmm.
So again the same keywords, I think very clear now.
Yes.
I think same thing is repeated here. No, it's different here.
No, it's different. Just the first slide is the same.
Yes. So making magnesium sulfate, how can you prepare magnesium sulfate? Magnesium with acid, right?
Acid. Mm-hmm.
It forms MgSO4 and H2 gas.
Mm-hmm.
There is no need to heat the mixture because magnesium is reactive metal.
Mm-hmm.
H2 gas is given off with a fizzing sound, fizzing, right?
Mm-hmm.
So magnesium sulfate is formed, which is crystallized by heating and then allowed to cool down.
Mm-hmm.
We get the crystal magnesium sulfate and MgSO4 7 water molecule called hydrated salt.
Mm-hmm.
Right? This process is called as a crystallization. How to make crystals? Do you know how to make crystals?
Sort of. You make all the water in the crystals evaporate.
Yes. First of all, we make a saturated solution.
A saturated solution.
And then it is heated until volume becomes 1/3. And then it is put on the cold water where all the crystals settle down. Right?
Right. Yeah.
And now making the sodium, potassium, and ammonium salts. All the potassium, sodium, and ammonium salt are soluble in water. Right?
Mm-hmm.
Alkali acid titration using suitable indicator. Do you know what is the meaning of the titration here?
Sort of. It's
Okay,
yeah. Can you go over that?
I'll tell you more detail. Suppose I take up here just a bit. This is a conical flask, and I put up here sodium hydroxide. You know, it's colorless. It's colorless, right? And I add here a very small drop of phenolphthalein. Right?
Yeah.
And then I take a stand and put up here a burette. Have you seen this apparatus burette in your lab? Have you seen the burette?
Yeah, I've seen the burette.
Right. And I take up here the HCl. And drop by drop, I allow the HCl to drop in.
Yeah.
As they go in, then what will happen? The NaOH will be neutralizing the HCl and form here NaCl and water. When all the OH ions are neutralized by the H positive ion, immediately the color of the pink will change into colorless.
Okay.
Right? This phenomena, this whole complete neutralization process is called as a titration. Right? This indicator, phenolphthalein, is pink in the basic medium and it is colorless in the acidic medium. So when you're adding drop by drop, it is getting neutralized. When it is completely neutralized and we are adding the last drop, as I'm adding the last drop, then what will happen? Extra drop will make the solution acidic. And the color will change from pink to colorless. Right? This is called a titration. Right? So we can use here different types of indicators like litmus, methyl orange, phenolphthalein. In the acid, they have a different color, and in the basic, they have a different color. Right? Okay. Now we prepare magnesium sodium sulfate crystals. How to make sodium crystals? Right? Sodium sulfate prepared by the NaOH with the sulfuric acid using the methyl orange. Right? So conical flask like NaOH and few drops of methyl orange. Right? Burette. In the burette we take up sulfuric acid. Again, I'll take up this. Wait. Again, in the conical flask we take up here sodium hydroxide, right? NaOH. And we add here methyl orange as indicator, which is yellow in color. And from the burette we add here drop by drop sulfuric acid. Right? Here we take up the sulfuric acid here, and drop by drop I am adding here sodium hydroxide. A stage will reach when all the OH ions will be completely neutralized by the H positive ion. Getting me?
Yeah.
Then in that case, what will happen then? Suddenly, one drop will be completely neutralizing the NaOH. Then the H positive ions will be neutralized by the OH ion. The extra drop will make it acidic. And then turn to the orange, and it means the complete base is neutralized by the acid. We get the solution of the sodium sulfate. This solution is concentrated by heating and then allowed to crystallize. Right? After crystallizing, we get the crystals of this hydrated sodium sulfate. Right? Do you know how do we crystallize it? Do you know have you ever made it or not? Practically.
For
you might have prepared the crystals of copper sulfate.
We've done copper sulfate,
yeah. The same procedure.
Oh, okay.
You practically in your school it might be with the copper sulfate because that is formed very quickly. Right. Now making NaCl, again the same procedure, only with the base adding here the HCl. Rest, the whole process is the same. Just read it quickly. In the burette, we are taking the HCl. In the flask, we are taking the NaOH. It is yellow in the base, and when we add the acid, end point, it will turn to orange, right? NaCl will be formed, and then it is crystallized by the same method, right? Any doubt now?
No, all good.
It's okay, right? It's not much difficult. Okay. And then we are heading here, making the ammonium sulfate. How to make it? Again, we take up the sulfuric acid in the burette and ammonia in the flask. When you add here sulfuric acid to the ammonia, drop by drop through the pipette to the burette, it will be getting neutralized and form ammonium sulfate without indicator, not with indicator, yellow to orange. When we get it, then we again crystallize it by heating and then allow to crystallize by cooling it down. That's it. Same procedure.
Okay.
Now making the insoluble salts. How to make the insoluble salts, right? Now we are discussing about the preparation of the soluble salts, and now we talk about the preparation of the insoluble salts. And that is possible by mixing two salts which would produce a precipitate. Right. For example, I'll take up one example here. For example, we have here silver nitrate, AgNO3, right? And it is a potassium chloride. If I mix them, what will be formed? AgCl and potassium nitrate. This is a white PPT form, white precipitate form. And at the floating mass, it's a test tube over here. In this test tube, if I take up here silver nitrate and drop by drop, if I add a potassium chloride, what will we get? We will get here these PPTs of AgCl. It is insoluble salt. Right? Okay. I think now it's all clear, right?
Yeah.
Like making AgCl, the same thing that I was explaining to you. A white PPT formed, Ag ions meets a chloride in the solution, and since attraction between them are very strong, solid AgCl is formed, right? That's it. Do you find any doubt here?
No, it's all good. I understand.
Last 4-5 points. Do you find any doubt here? Acid, alkali, titration, indicator, precipitation reaction, and the PPT precipitate.
I get it. I understand it all.
All good. Now, what do we mix together to make insoluble salts? To make insoluble salts, we must remember all the nitrates are soluble. All the potassium and sodium salts are soluble. Make two solutions, the PPT will be formed. Right? Like we have lead nitrate and the sodium iodide. They are colorless, and after mixing, we get the lead iodide, which is yellow PPT. Barium nitrate, potassium sulfate, we get the barium sulfate, white PPT. Right? So, summarizing, is a salt soluble? If no, use a precipitation method. Right? If it is soluble, then is it a sodium or potassium salt or ammonium salt? If no, react with the acid and form excess of solid metal. If yes, then use a titration method. This is how to make the salts. Right? Any doubt here?
No.
Now, what is Arrhenius theory? Arrhenius says The substance which gives H positive ions in the aqueous solution is called as an acid. And the alkali is a substance which is the source of the OH ion, that is a base. Right? So HCl is a acid, it is giving H positive ion. NaOH is a base, it can give the OH ion in the aqueous solution. Right? So acid is a substance, according to the Arrhenius, the substance which gives the H positive ion. Can you tell me any other example which is not HCl?
Of an acid?
Yeah, except for HCl. Do you find do you know any other acid?
Nitric acid? HNO3?
Yeah, nitric acid. Good.
Then sulfuric acid. And yeah. Then I don't know, I can't really think of anything else.
And do you know any other
Carbonic
base?
acid.
Do you know any other base?
Yeah. There's sodium hydroxide, calcium hydroxide, ammonium hydroxide.
Yes.
Magnesium hydroxide.
Good. And now we have another theory now, right? The substance which acts as a proton donor is a acid, and a proton acceptor is a base. It's a Laurie-Bronsted theory. I'll discuss in detail now. Suppose I say, here I have ammonia, right? Ammonia has this pair of electron here, and I'm adding here HCl, H positive and Cl negative ion, right? So what happens now? This pair of electron is donated to the H positive ion here. Now it will form here NH3, one more, and it will become positive charge and the chlorine. Right? This is a proton acceptor. Proton acceptor means it is a Laurie-Bronsted base, and this is a proton donor. It's a Laurie-Bronsted acid. And finally, by combining them, we get here ammonium chloride, and a salt is formed. Is that clear?
Yeah.
Similarly, you can give one more example: ammonia plus HCl plus water. In this case here, like this, we have water is here with two lone pairs here, and I'm adding here HCl, H positive, Cl negative ion. Now what will happen? This will donate electron pair to the H positive ion and accept a proton, and we get here H3O positive and Cl negative ion. So this is a proton acceptor. It is a Laurie-Bronsted base. This is a proton donor. So it's a Laurie-Bronsted acid. Right? This is another theory, that is Laurie-Bronsted concept. So this thing we have done, right? So acid and a base combine to form a salt.
Yeah.
Right? So more acid base reaction here. Now see there, oxide plus water to form NaOH, copper oxide plus sulfuric acid to form copper sulfate, ammonia plus water to give ammonium hydroxide,
Mm-hmm.
Okay. The keywords, are these clear?
Yes. Yeah, they're all clear.
Yeah. Do you find any doubt till now?
No, all good. I understand.
Okay.
Let me send you another.
Okay. This is a chemical test for gases, right?
Mm-hmm.
Test for hydrogen. How to test? Suppose in a particular reaction,
Mm-hmm.
H2 gas is coming out.
Mm-hmm.
So just bring a lightning candle, a spark near
Mm-hmm.
the entry point. Then H2 will combine with oxygen in the air and that will give a pop
Mm-hmm.
sound. A squeaky pop.
Okay.
It explodes.
Mm-hmm.
And that is a conformity test for the presence of hydrogen gas.
Mm-hmm.
Right? Presence of the oxygen. Bring a glowing splint in the mouth or test tube. The glowing splint will reignites,
Mm-hmm.
and it's a conformity test of the oxygen.
Mm-hmm.
Right? Getting me?
Mm-hmm. Yeah.
And test for the carbon dioxide, pass it through the lime water, the lime water will become milky, simply.
Mm-hmm. Mm-hmm.
So calcium hydroxide reacts the carbon dioxide to form calcium carbonate and water.
Mm-hmm.
So it's a conformity test that
Mm-hmm.
is carbon dioxide. But if you continuously provide the carbon dioxide, the calcium carbonate formed will again dissolve in water and form a soluble calcium carbonate.
Mm-hmm.
It means if we add excess of calcium of the carbon dioxide, the calcium carbonate formed, the white PPT formed, will dissolve.
Mm-hmm.
Right? It's a conformity test of the carbon dioxide. Now, test for the chlorine. How to test the chlorine gas? Right?
Mm-hmm.
Hold a piece of the damp blue litmus paper
Mm-hmm.
or universal indicator paper.
Mm-hmm.
The blue litmus paper turns red when it is bleached. Bleached means it is treated with the chlorine.
Uh-huh.
Right? The blue to red.
Mm-hmm.
It's a conformity test that the compound is containing the chlorine.
Mm-hmm.
And ammonia, since it is a basic, it will turn the reverse, red to blue.
Mm-hmm.
Right?
Mm-hmm.
Any doubt?
No, I understand.
And testing the presence of water, right? Whether the compound contains water or not. Like we have a using the anhydrous copper sulfate. Can you tell me what is the color of the anhydrous copper sulfate?
It's white.
White, yeah. And if it comes in contact with the water, that will form hydrated then.
Mm-hmm.
It means it has absorbed water
Mm-hmm.
and that will turn to blue. Suppose in this test tube we have water, then the white copper sulfate will turn to blue.
Yeah.
Right. If it is an acid, if it is a sulfuric acid or any other thing, it will not turn to blue. Suppose here we have only alcohol. Alcohol will not turn the copper sulfate to blue.
Mm-hmm.
It is only the water that will turn, right?
Mm-hmm.
Using dry cobalt chloride, dry cobalt paper, blue to pink.
Okay.
Right?
Mm-hmm.
When it comes in contact with water, it turns to pink. Now, determine the purity of water now. How to determine purity of water? Melting point of water is exactly 0 degrees Celsius and the boiling point is 100 degrees Celsius.
Mm-hmm.
Right? If the water is not pure, then the melting point and boiling point will not be exactly as it is.
Mm-hmm.
Freezing point will be less and the boiling point will be more.
Mm-hmm.
That will be determination of the fact that it is right.
Yeah.
Then we have testing of the ions, flame test.
Mm-hmm.
Different elements show different color in the flame.
Mm-hmm.
Right? What we do is we take up a platinum wire and salt is fit into it and then we heat it in the flame.
Mm-hmm.
Right? And if the color changes to red, it means it may be lithium. If it is golden yellow, it may be sodium. If it is purple, it may be potassium. Orange color, calcium. It is blue-green, then it may be copper.
Okay.
And these are the conformity test of the presence of particular salts. Right? I think these terms are clear now. Hydrous, anhydrous, hydrated, purity, and salt. Any doubt till now?
No, all good.
Oh, good. Okay. These things?
Yeah, we do it. Yes, we've done it
Okay.
before.
Now testing the cations using sodium hydroxide. Right? Cations means the positive part of the salt. So dissolve the salt in distilled water and add the same volume of the dilute NaOH. If the solution becomes cloudy, then the precipitates or the metal is formed. And most metal hydroxide are insoluble except for sodium hydroxide, potassium hydroxide, ammonium hydroxide, and the barium hydroxide. Right? So suppose we have copper ions, and we will get the blue color solution of the sodium hydroxide.
Yeah.
And it's a conformity test of the presence of the copper ions. Right? Blue color PPTs are formed using the test of the ions like ferric ions. With the ammonium hydroxide, it will give you a ferric hydroxide and gives a brown color PPT here. Right? And it's a conformity test of the presence of the iron ions. Do you remember? Do you understand this reaction now?
Yes.
Yeah. And with this ferrous 2 positive ion, it will form a orange brown color of the ferric hydroxide. Green PPTs are formed. Testing for ions. Right? Testing for ammonium ion. With the ammonium hydroxide, that will form ammonia gas will come out of it. Ammonium chloride is salt and NaOH, we get ammonia gas coming out of it. Right? And if it is basic in nature, then it will be proved by the adding the litmus paper. That will turn the blue to red. So testing of the ammonium cation using NaOH summary we can give here. Right? Blue color PPT with the copper ion. Ferrous will give you green PPT. Ferric will give you orange PPT. But with ammonia there is no any PPT formed, but you get the ammonia gas produced, which can be tested by passing the HCl. We get the fumes over there. Right? Now testing the anions. How to test the anions now? Suppose we have carbonate ion here, right? We add here nitric acid. Zinc nitrate is formed, right? Zinc nitrate is formed. Gas formed is carbon dioxide, right? Fizzing effervescence formed, and it confirms the presence of the carbon ion. If the gas comes out with the bubbling, some bubbles comes out. Fizzes. Getting me? All these things. Sulfate can be detected by the precipitation reaction. Right? Suppose we have we add here sulfuric acid. Simple. We get white PPT here. BSO4, PbSO4, white color PPT. Chloride bromide iodide can be by reacting with the nitric acid with the AgNO3. If you get a white PPT here, it means AgCl, creamish AgBr, yellow AgI. Right. Suppose I have a salt of the sodium chloride. I treat it with the sodium silver nitrate. Then what will I get? Like this. Wait. Suppose I have here NaCl salt is with me. I am reacting it with the silver nitrate. Then I will get the white color PPT of the AgCl. Right? If I have a salt of the potassium bromide, I am reacting with the silver nitrate. Then what will I get? AgBr, the creamish color, right?
Yeah.
If I get a cream color here PPT, it confirms that it is containing the bromide ion. Suppose I have potassium iodide and react with the AgI, AgNO3. it will form here AgI plus
KNO3.
it will give you the PPT of, right? Yellow color PPT. These things have to be remembered, right?
Yeah.
So we can make a summary here for carbonate ion, sulfate, chloride, bromide. Any doubt? Just
No, all good.
you have to just go through it again and again and remember it.
No.
Right? Keywords are clear.
Yeah.
Hydrated, anhydrous, PPT, and salt. Right?